Okay, Bismillahirrahmanirrahim. This video is the second one in, in the spatial discretization using shell element, Abaqus shell element for the reference beam. Okay. In the previous video, we show how to simulate the, the reference beam in chapter 1 using shell element, but with neglect the width of the support, where simulate simulate the support as a line support located at the center line of the support the actual support actually has a width in our model. If we return to our to Abaqus model from a previous lesson. Okay, in our model, the actual support that has a width has been replaced with a knife edge support. From one end we have hinge support, from the second end we have roller support, but in both cases we neglect the width of the support and simulate the supports as knife edge. In this lesson, of course, as I said previously, this support has been located at the center line of the support. That is mean 150 far from the end of the ends of the beam. Okay. Today, in this lesson, I intend to simulate the actual width of the beam, but still I intend to use simple supports, hinges actually in both cases, instead of the actual concrete support. Okay. One of the skills can be revealed in this model is how to move, or how to update our previous model to be more suitable for a new case. Go to file, save as. Okay, instead of shell reference beam without supports, here we have with support. Yeah, with support. Oh, okay, with support. Okay. The second step, I go to part here. Go to part, open the beam feature. Yeah, feature. Here I intend to move this datum plane, the second datum plane actually, not this one. Yeah. The datum plane 2 is the datum plane on the other end. Yeah. Then we here talking about datum plane 3. Yeah, datum plane 3 and datum plane 4. Datum plane 3 and datum plane 4, from the other end, are located from the previous simulation, are located at the center line of the beam. I intend to move them to a new location, 300 millimeter from the beam ends, to be able to simulate the actual width of the support. Yeah. Go to data, right click, edit. Instead of 0.1/2, I will adopt 3. Yeah. Apply. Okay. Go to datum 4, edit. Instead of 0.1/2, 0.15, I will adopt 0.3. The second modification related to load, more specifically related to supports actually. Go to initial, go to supports from hinge, edit, edit region. Okay. Instead of line, I will assign the hinge support to two surfaces actually. Okay, two surfaces. Okay. The second one, in the previous model, I adopt roller, knife edge roller supports. Okay, here I will make two modifications actually. The first one to change the roller into hinge, hence this one, the first hinge. I will change the name for first hinge into left or left. Yeah. The second one to be changed to hinges also here, hinges, but right. Okay. Secondly, I will edit here. Add, okay, region. Rotate here. Save. Go to mesh. Okay. Of course, I have a problem in mesh, disruption actually in mesh due to moving of data plane. Okay. Change from assembly to part. Yeah. Is the same previous mesh. Yeah. Mesh. Yes. Then I'll go to job. Yeah. Job. Rename. Instead of without, I will adopt with support. Okay. This makes the job name more inductive on one hand, and to avoid the confusion in the software on the other hand. Yeah. Submit. Okay. When the analysis is complete, we can review the results. Okay, review the results. Yeah. Review the results. Go to results. Go to deformation and go to U2 to review the deformation, vertical deformation along y-axis. Okay. The solution indicates that deformation of 3.88 times 10 to the minus 3. That is mean we're talking about the deflection of 4 millimeter according to new model. Comparing with the deflection, the initial deflection of 13.7 according to the traditional solution of strength of material. Hence the actual or more accurate simulation of deflection of the support has a significant effect on deflection. From the deflected shape, we noted that if this actual support or a more accurate support simulation is adopted, we have a concave from this side, maybe it's more clear. We have concave curvature. Almost we have a region of negative moments, negative stresses. Okay. Hence, the stiffness, the overall stiffness of the beam is significantly increased, and the deflection is consequently decreased. Of course, this simulation maybe include an overestimate of the overall deflection of beam, since here we use hinge supports. Then we implicitly exclude two possible movement modes. The first one, the actual support in the reference beam. Here in actual support, we may have uplift. Okay, this uplift is excluded when we use hinge that can resist tensile and compressive forces, tensile of course in this case. And we have possible sliding mode that also excluded when we use hinge, where the displacement is totally restrained along z axis. Okay, thank you very much for your time and for your listening. Thank you.